Alright, so in this video we're going to go over the surface area of circular solids, and we're going to go through three of them. We'll go through a sphere, we'll go through a cylinder, and we'll go through a cone. We'll have an example for each, and we'll kind of run through the formulas. So the surface area formula for a sphere is 4 pi r squared. Now, for the purposes of this video, you're just going to take my word for it that this is the formula. And if you want a silly way to remember it, you can think of it as 4 circles. Think of it as 4 times pi r squared. So the surface area, if you were to paint the outside of a sphere, you'd paint it with 4 circles worth of cubic units. Okay, so like here's a sphere. Let's say I draw one right here. Here's a sphere. Here's our radius, and it really makes sense, that you're going to need to find the radius because you really always have to. So you'll find your radius, you'll square it, and you multiply by pi, and you multiply by 4. That's the surface area of a sphere. However, here's what's interesting. The surface area of a hemisphere, that's like, think of like the northern hemisphere and southern hemisphere on the Earth. That's like a half of a sphere. You actually have to be really careful. So imagine if I took the sphere on the left and I kind of chopped it right here. And it would look like this. It would look something like that. Now, here's what's interesting. The surface area of a hemisphere, it depends. So imagine if I chopped this sphere, and let's say that this base is filled in, or let's say it's going to be painted. Well, this is what's interesting. You could say, okay, you chopped it in half, so it's 2 pi r squared. However, if this region is also going to be painted, this circular base on the bottom, you'll have to add that to it. And so the surface area of a hemisphere is going to be 3 pi r squared. Now, keep in mind, if you had, let's say, let's say you were thinking about the cloth for a portion of a hat, though. Then you would have the same picture as above. However, if it's a hat, this region is not going to be filled in. You're just going to be looking at the cloth. So then the surface area of this thingamabob is just going to be 2 pi r squared. So the key difference between this picture and this picture is that imagine on this picture we're not painting that base, or if you will, but on this picture we actually have a circle there that we are painting. It is part of our surface area. So on our party hat, though, if you think about the cloth, for our baseball hat, we wouldn't have cloth right there, so that would not be incorporated in the surface area, so we'd only have 2 pi r squared. So you have to pay attention. Is the base included? The surface area will be 3 pi r squared of your hemisphere. If the base is not included, it will only be 2 pi r squared. Okay, good. So here we're talking about the cylinder. We're going to talk about the lateral surface area and the total surface area. Okay, so here we have a cylinder. Now, the lateral surface area, first of all, we'd have like a radius, let's say right here. Now imagine if I use some handy dandy scissors and I kind of cut right along here. If I cut up and then I unraveled the lateral face, the part that's not a base, I would have a piece of paper, and I've done this piece of paper demo in class. So then you might say, well, what's the lateral surface area of a cylinder? Well, it's going to be whatever this rectangle is, and since it is in fact a rectangle, we'll have to figure out what the base is, and we'll have to figure out what the height is. Well, pretty clearly, the height here is the height of our cylinder, so I'm just going to kind of keep that, if you will. Keep that h there. But the base, you might ask yourself, well, how long is this? We know it's going to be the height of the cylinder tall, but how long is this? Well, this region right here, if you were to wrap it up, you would actually have the perimeter, or the distance around, otherwise known as the circumference of the circle. And I've probably done this piece of paper demo. So the base is actually going to be, what is the dimension, what is the length of the base? It's going to be the circumference big. This right here is the same as that, so that circumference will be 2 pi r. So then if you were saying, well, what's the lateral surface area, meaning the surface area of the non-bases, because we know the bases are the two circles on this, let's say. Well, the lateral surface area will be base times height. 2 pi r, that's the base, times the height, h. So that's the lateral surface area. The total surface area will be the lateral surface area plus, well, what are the bases? The bases are circles. The area of each of the bases is pi r squared. So you have 2 times pi r squared, that's your two bases, and then you have your 2 pi r h. This is the total surface area of a cylinder. Okay, very good. So here we have a picture of, let's say, some sort of like a gel cap or something. Think of this as some sort of a medicine. And let's say, we were going to like kind of paint this medicine like with some sort of, let's say, like a sugary coating paint, and we were going to paint the entire outside. There might be some sort of a question where we might want to know, what is the total surface area of this gel cap? Okay, so let's say we're given some information. Let's say we're only given the height of the gel cap and the length of the gel cap. Well, before we even deal with the numbers that we're given, we'd have to think about, well, what sorts of things are part of the surface, or let's say will be touching the air. Well, if you think about it, those two portions of the cylinder will not be touching the air. So if I had to develop a strategy, even before I put the numbers in, I think I should have had the strategy up beforehand, but it's all right. The total surface area of the gel cap is going to be, well, in the middle I know there will be the lateral surface area of the cylinder, only that portion, because we're not going to be able to paint the bases, they're not exposed to the air. And then I see that I have a hemisphere, and I have another hemisphere. So I kind of oriented this like the three parts: hemisphere, part of a cylinder, hemisphere. I've got my three pieces right here. And so really, put those two hemispheres together, and you have the surface area of a sphere plus the lateral surface area of the cylinder. Those two parts together make up the total surface area of this gel cap. Let's say we were going to paint this red or something, and we wanted to know how much sugar-coated paint do we need. Oh my gosh, this chair is making like really annoying noises. I don't know if you can tell. But so we have our strategy. Just one little idea as well. So the total surface area, if we put those two hemispheres together, we'll have a full sphere, and then we'll also have the lateral surface area of the cylinder. So the surface area of the sphere, we know that that's 4 pi r squared, and we know the lateral surface area of the cylinder is 2 pi r, that's the circumference, by the height. Okay, so now, based on all the clues and hints we've been given, we should really say that that radius is 2. Keep in mind that radius can also go in this direction and down here as well. Same thing, 2, 2, and 2. So I'm going to even label those in. So those are really, really important. So now, if you think about this dimension, this length, or height, depending on how you're looking at it, we've used up 2 on this radius and 2 on this radius. So you might say, how much is left? Well, if we have 12 in total and we've used up 2 and 2, we'll have 8 in the middle. Means we know the height of our cylinder is 8. Okay, what else? Oh, really, I don't know if I was clear enough on this, but we knew that this was 4. This is like saying the diameter is 4. That's how we got that each radius was 2. So now I think we have all the dimensions we need for our total surface area of the gel cap. Well, 4 pi r squared, the radius is 2, plus 2 pi r, the radius is 2, and the height, remember, is 8. We said we used 2 and 2 on radii, so we had 8 in the middle to make up a full distance of 12. Now let's just put it together. So the first region makes 16 pi. We'll square the 2 first by PEMDAS, making 4. 4 times 4 is 16 multiplied by pi, so we have 16 pi in our spheres, and then the lateral surface area of our cylinder, 2 times 8 is 16, times 2 is 32, multiplied by pi. Since these are like terms, we can put them together. 48 pi square units is going to be the total surface area of our gel cap. And I'm assuming the units would be very small because this is like a little thing of medicine. Alright, cool. So be sure to organize yourself just as we did right here, where we came up with the strategy, the formulas, we found what we needed, we showed all of our work. Total surface area of the gel is this, which is this. Final answer, box it, and have a good day. So now for a cone, here's my handy dandy cone right here. We'll have some radius here. Now keep in mind, if you kind of think of this, we learned about this in pyramids. I'm going to put an L right there for that blue line. That blue line is going to be referred to as the slant height. Well, the lateral surface area of a cone, and we can prove this in class, but here you're just going to have to take my word for it. The lateral surface area of a cone is going to be pi times the radius times the slant height. Okay, now the total surface area of a cone will be the lateral surface area plus the area of the base. There's only one base here. That base is a circle, so its area will be pi r squared. And we know the lateral surface area is pi rl. So if we put these two things together, we will have the total surface area of our cone. So now what we're going to do is we're going to find the total surface area of a cone. And so we know that that's going to be equal to the lateral surface area of the cone plus the area of the base. So here is our cone. Let's say we're painting every portion of this. This is like a fang for a dragon or perhaps a dinosaur costume, and we want to paint the whole thing, even the part that's going to be attached to the gum. Just go with it, all right? So let's say I tell you this length is 8, and let's say I tell you that this height is 3. All right. So now what we're going to do is we're going to kind of go with this, and we're going to find the total surface area of the cone. Keep in mind the lateral surface area we know is pi r l, and the area of the base is pi r squared. So really, we need to track down the radius. I was annoying and I gave you the diameter. So the radius is just going to be 4. That's crucial. Now from there, we need to also know this slant height right here. Now keep in mind, we aren't going to use the height, which we could also call the altitude. We aren't going to use this height because that's on the inside, and surface area is only stuff on the surface. So it makes sense to have to find this slant height. Well, by triples or the Pythagorean theorem, you should recognize that the slant height is 5. So now we can really just find the total surface area of our cone. We've got pi, the radius is 4, and the slant height is 5. That's the lateral surface area. And then the area of the base is just going to be pi and multiplied by the radius squared. So we've got 20 pi plus 16 pi. That'll be 36 pi square units, and that's the total surface area of our cone. And now, 2 for you. First question, find the total surface area of a cone with radius 8 and a height or altitude of 15. And number 2 is going to be to find the total surface area of... So you've got this picture on the right, and I'll also tell you that the circular base that's in a few of those shapes, I'll tell you that its diameter is 14. So now again, you need to find the total surface area of this funky shape right over here. Make sure you draw it. And I'll also tell you that the diameter here is 14. And good luck and go for it. Now keep in mind, you're only painting or finding the surface area of the things that are on the surface, so you will not include those circular bases. I like to X them out to remind myself. All right, good luck, have fun, good night.